All right, hello. Let's get this show on the road. Welcome to the last day of class. Some reminders of stuff that hopefully you are already aware of before we talk about the exam. Your assignment is due this Friday by the end of the day. You are welcome to use late coupons on that assignment if you want to. It doesn't matter to me. It's up to you. The one thing that I do want to point out is that if you are intending to get this done on Friday, please be aware that while I do intend to check Piazza at least once on Friday, as I think I mentioned earlier, it's my birthday and I've got a hot date with my wife that night. We're going out to see Wicked, and if she catches me checking Piazza during the play, I think we might have to get a divorce. So I'm not going to be checking Piazza, basically, is what I'm trying to say, late Friday night. All right? I'm happy to help you out however I can before then. I've got my regularly scheduled office hours tomorrow. I will check Piazza during the day on Friday, like normal business hours-ish, kind of, on Friday. But Friday evening, I will be out and about. So please plan accordingly if you're trying to get the assignment submitted by Friday night. Homework 4 grading is going along. I'm still hoping to get those done by the end of the week, and I don't see any reason why that's not going to happen. I'll keep you posted on those grades as they progress. Does anybody have any questions about homework assignments or that kind of stuff before we hop into exam related things? Question? No? Okay. Yes.
When doing the comparison operators for the Mongo filter, the queries, Mongo does them where like the keys are not strings.
The keys are not strings?
At least in the Mongo specification, there's like some weird distinction between having a key and then like a string that is specifically in quotes.
Okay.
That I think I'm a little confused about because it seems like our keys in our strings. So for example, what I'm getting at is like, is it possible to have like a quote $GT as a greater than instead of just $?
Oh, I don't necessarily see a problem with that.
Okay. I'm
certainly, of all the things in the Mongo spec that you could implement on this assignment, that's probably one that I'm worried about the least. So, if it makes more sense for your implementation to enforce quotes, then enforce quotes. If it makes more sense to not do that, then don't do that. Use your tests to show me what your implementation can do and how it works. Yeah.
Yeah, so related to that actually, so say you have a valid document, and when you try to access it's a field, say like product.quantity.
Yes.
So quantity is a field in the product document.
Yes.
And that way MongoDB enforces you to use quotation mark, say like product.quantity, quotation marks surrounding.
Okay.
To tell the database is trying to access a valid document. So and normally you don't have the quotation mark, you just trying to access like a normal field. So can we not make the distinction? Can we just say, if we say dot, then we... Again,
it's not going to bother me. You're not being graded on this assignment based on how tightly you stick to the Mongo spec. I mean, I do expect you to try and do your best to reasonably stick to the Mongo spec, but if you take some liberties for the sake of simplicity or to make your lives a little easier on this assignment, then I will be A-okay with that. The way this assignment is graded is I'm going to look at your tests. I'm going to use those to help me understand the way that you expect the behavior of this program to work, and then I will grade your assignment based on that information. So in a sense, your unit tests are telling me how you want your assignment to be graded. You have the flexibility to influence how I look at and grade your assignment. So use your unit tests to tell me that story.
So we're only responsible to pass all unit tests.
I actually don't think that's true. I think if you give me unit tests that don't pass, that's still valuable information. You are telling me that there are specific features or specific functionality that you believe your implementation should have, but for one reason or another, you didn't get around to it, it doesn't work, it doesn't, whatever the case may be, right? I think it's still valuable. I think the presence of unit tests that don't pass is not necessarily an automatic deduction on the assignment. Yeah. It could be. I don't want to say that I'm not going to take any points off of that kind of stuff. It could be, but it's not necessarily the case. There's a lot of open-endedness on this assignment. There's a lot of wiggle room in terms of what you can do on this assignment. And so I'm trying to judge your work as a whole, not based on the individual parts necessarily, if that makes sense.
Yeah, so I'm just wondering, will there be like other tests like tests other than our unit
Nope.
tests?
Nope, wasn't planning on it because everybody's implementation is going to be so different that would not be practical. Would not be practical. I understand that having this degree of flexibility, this degree of freedom can be a little bit scary in some ways. But it's also hopefully a little empowering to know that you can create something in that manner. And I mean, it's an excellent example of what life's like in the real world, right? When you get out there and do actual programming stuff out in the wild, that's what you're going to be doing. So I think it's great practice. Any other questions I can address about any non-exam related stuff? We'll talk about the exam in a moment. Anything not related to the exam that you would like to have a chat about before I switch over? Yes? To pass the class? The grading scale is on course policies page on Canvas, I believe. I'm not entirely sure what you're asking me. Are you asking me about pass fail? Yes. The cutoff for pass fail, I believe, is a 70. I think I am fairly certain it says something about that on the policies page. I could be wrong, but generally that's information that's found on the policies page. Any other questions I can address before we talk about the exam? All right, then let's talk about the exam. So the exam, all right, just to kind of set the stage, I'm gonna go over some of the logistics stuff first for the exam. We'll do a brief overview of the topics that can be, that you can expect to see on this exam. And then once we've done that, I'll turn the floor over to you all and let you ask any kinds of questions. We can do any practice problems you want. We can go over past exams, which, by the way, if you haven't seen already, please note that there's a post on Piazza with a couple of past exams on it that you can use to help you study for the exam. Also, another logistical note that I forgot. I did speak with my TAs, and at least some of them have agreed to hold office hours next week prior to the exam. I don't have times for you yet, but that will be coming. I will also be holding office hours next week. I don't know what times those are going to be yet, but as soon as I have that information, I'll make a post on Piazza. So there will continue to be office hours next week as well. So let's go ahead and have a little chat about the exam. All right. The exam is going to be on Monday, December 16th. Today is the 4th, I guess. So 12 days from today. It's here. I'm fairly certain. It's in this room from 3:30 to 5:30 p.m. So it's not at class time. But the good news is if you show up at class time, you'll be an hour early, so you're not going to miss it. So, if you set your alarms for 2:30, that's okay. That's fine. But if you have accommodations for extra time, please get that set up with Cornerstone as soon as possible. They're very strict about those kinds of requests, so please get that set up as soon as possible. Like the past exam, it's open book, it's open notes. You can bring anything that you want to help you on the exam as long as it does not use electricity. So no phones, no calculators will not be necessary. Certainly no computers or anything like that on the exam. But any notes you want to bring, anything else, you are more than welcome to do so. All right, we good? Any questions on where, when stuff? It is not cumulative. That's we're going to be going over. You asked me that on Monday, didn't you? Yeah. Fair enough. I understand. Yeah. So what's going to be on this thing? Everything that we have talked about since the midterm exam. So I think the one important omission is B+ trees are not on this exam, right? B+ trees were on the last exam. That was the last topic that we covered before the midterm. So that will not be on this exam. Everything that we've done after the midterm is fair game for this exam. So we started with transactions and the kinds of problems that can arise with concurrent operations. There were actually 4 problems that had names in particular. Does anybody remember the names of some of those issues with concurrent operations that we talked about? I'm not even looking for all 4. You can give me one or two. I'm sorry? Oh, you're getting ahead of me. That's one of these guys. Yep. I'm going to ask you those 2 in a second, so good looking out. What were one of the 4 problems with concurrent processes that we talked about? So deadlock's definitely a problem, but not one of the 4 I'm thinking of. In the back? Lost update. Yeah, that's an example. Lost update is an example. What was it? Temporary update problem was an example. I'm not even sure I can pull all 4 out of my brain at this particular moment in time. But there were 4 of them, I believe, that we spoke about in class. The transactions are attempting to help regulate. We talked about, the general functionality of transactions, how they start and then are committed, which then makes a permanent write into the log files. And then we could talk about what Sarah wanted to talk about with the ACID properties. She nailed the A for us, atomicity. What's atomicity mean? All or nothing. I run every operation in the transaction or I don't do any of it. So if a problem happens halfway through, I'm rolling all the changes back that were done up until that point, right? We got 3 left. Who can give me one of the remaining 3? Isolation. So what's that referring to? Anybody else? Yeah.
Failure of one transaction doesn't affect failure of others.
We can make it even more general. That's true. We can make it even more general than that, right? A transaction is operating as if it's the only transaction in the world, right? There could be 1,000 other transactions operating at the same time, but I don't know. I'm in my bubble, right? I'm in my bubble. I can only see what I'm doing. I have no idea that other transactions even exist or not. All right, we got 2 left, the C and the D. Who can help me out? Yeah, in the back. Consistency. All right, so what are we talking about with consistency? Yeah, go ahead. One valid state to another valid state. So, or I think a slightly different way of thinking about that is that the database may not be in a valid state if I look at it while the transaction is running, right? Over the course of the transaction, it may leave the database temporarily in an invalid state, especially if we're updating relationships and things like that. But once the transaction has finished, it should get the database back to a consistent state. And then the D is the last one we got. Durability. Great. And what do we mean by durability? Log files are what we use to enforce durability. So what does that actually gain us then? That actually deals more with atomicity than durability. That's true. It deals more with atomicity than durability, though, I think, in my opinion. What do we mean by durability? Slightly different concept. Yeah. Yes, once a transaction has finished and committed, those changes are permanent, forever part of the database. forever part of the database. So we use log files to help protect us against failures that might cause transactions to be lost. Good, excellent. We also spent a lot of time talking about scheduling, how transactions are scheduling. Specifically, we spent a lot of time talking about conflicts. So what are the kinds of conflicts we're interested in? They're actually the only two kinds of conflicts that we consider. Read-write conflicts and write-write conflicts. Basically, if there's a write involved, there's a potential for a conflict, right? And so with this idea of conflicts in mind, again, the goal here was not to avoid conflicts entirely, but to be aware of the conflicts and try to come up with a schedule that is serializable. What does it mean for a schedule to be serializable? What is that concept referring to? Yeah.
If you were to do all the transactions in serial, it would have the same conflicts as the current schedule.
Exactly. So we say, whoops, I hit a button. We say that, I hit two buttons. We say that a schedule is serializable if it has the same types of conflicts that a serial schedule would contain. It's a concurrent schedule that has the same conflicts as a, it's a non-serial schedule that has the same conflicts as a serial schedule. The idea there being that, if the serial schedule can't avoid the conflicts, then why should we enforce the non-serial schedule to avoid those conflicts, right? If they're at least as good, then that should be good enough for our purposes. All right, great. And so then we had a method to check for serializability, right? We could draw a precedence graph to check to see whether a schedule is serializable or not. But we also talked about why that's not often used in practice. Why not? We drew a few of those graphs, and then I said, we never draw those graphs. That doesn't actually happen. Why? They're slow. They could get quite large, right? They could get quite big. Maintaining them, it takes time. And actually think about the other implication is the idea is that you're throwing a random pile of transactions out there and then hoping that it works. And if it doesn't work, what do you have to do? You have to pick them all up and throw them back out again and keep checking until you find some combination that works. So that's time consuming. So there's a better way. There's a better way of generating serializable schedules where we can guarantee that a schedule that is generated is in fact serializable, and it involves the use of locks. So we talked about a few different types of locks, but the kind that we spend the most time talking about were called binary locks. So the two types of locks in a binary lock system are read and write. So I'm going to lock things whether I'm reading, I'll take a read lock, or if I'm writing, I'll take out a write lock. And there were certain rules that those locks had to obey, correct? Which lock is more restrictive, read locks or write locks? Write locks are, because I can only ever have one of them on a given piece of data at a time, correct? Read locks, I'm allowed to have multiples. I'm allowed to have as many of those as I want on a given piece of data at a time. And so by introducing this idea of locks, we can guarantee serializability by using two-phase locking. What do I mean by two-phase locking? What does two-phase locking tell us to do at a basic level? Yes. Oh, sorry.
Acquire all locks before the transaction, before any operation starts.
Yeah, so the first phase is gathering. I'm going to acquire all the locks that I need to perform the transaction. I'm not going to release any locks until I have acquired all of them. So the second phase is releasing locks. Those are the two phases within two-phase locking. But actually, there are different kinds of two-phase locking, right? So what we just described is the most basic form of two-phase locking, but there are other versions, other flavors of two-phase locking that exist. Like what? Who can tell me a different version of two-phase locking that we talked about? There's one that we spent quite a bit of time discussing. Some other less important ones. Anybody remember? Yeah, go ahead, Adam.
I think there's strict two-phase locking.
Strict two-phase locking. So that's an important one. That's a very common way of handling two-phase locking. What does strict two-phase locking tell us? How does it modify the two-phase locking formula? Yeah, go ahead.
Not going to release any write locks to the very end of the transaction.
Yep. So we're going to hold on to all of our write locks until the very end of the transaction. Why? What is the benefit that we get out of that? What is the benefit that we get out of that? Yeah.
The transaction order tell any data that we change would not be read by other things.
We are protecting our rights from being read by other transactions before they have been committed. That's exactly right. That is exactly right. If we allow ourselves to release write locks before the transaction is committed, it's possible for another transaction to read that modified data, and then our transaction to fail, which would roll back that right, which is not a pleasant situation to be in. So strict two-phase locking is pretty standard. Not the only way of doing it. We also talked about conservative two-phase locking, which is very similar, but perhaps even more conservative than strict two-phase locking. I feel like there was another one that I'm just not remembering right now, but it must not be that important if I can't think about it. So great. But the downside, the cost of two-phase locking is that we now have to worry about deadlock. So deadlock occurs when I've got two transactions that are, or it could be more than two, honestly, but the simplest case of deadlock is I've got two transactions that are waiting on a resource from each other, and neither one can move forward until the other one releases a lock, but since they're waiting on each other, it just sits there indefinitely, and the program does not progress. The transactions do not progress any farther. We talked about many different ways that we can either detect or avoid deadlock. Does anybody remember some techniques to deal with deadlock? I'm sorry?
Kill one.
I can kill a transaction, right? If I detect that two transactions are in a state of deadlock, I can just pick one and say, oh, you're done. Start over again. That should allow the remaining transaction to proceed, correct? And there are lots of different criteria that can be used to decide which transaction should be stopped in that particular scenario that we discussed. Is that an example of deadlock detection or deadlock avoidance? It's detection. It's detection. So an example of avoidance would be what? How do we avoid deadlock altogether? A couple ways to think about this. So one way is something I just talked about. Conservative two-phase locking says grab all of your locks before the transaction even starts, which means that if there's a lock that I cannot acquire, then I will not be able to even start the transaction. That actually is itself a form of avoiding deadlock. You can't have deadlock if you never start the transaction, right? Thinking guy meme, right? That's what conservative two-phase locking is telling us, or trying to accomplish. There are other techniques that we talked about. We don't need to go into detail on each and every single one of them right now. We also talked, finally, on the topic of locks about granularity. So what is granularity referring to when I talk about locking? We talked about granularity in other contexts as well, but in the context of locking, what is it talking about? Yeah.
What how specific the lock should be, like a specific cell or like
Yeah, exactly. Yeah. What exactly is the amount of stuff that I am locking? Am I locking a single cell? Am I locking a row? Am I locking a page or an entire file or an entire database, right? We can vary the degrees. The idea there being that if I am careful about how I choose the granularity, it should give me better performance by allowing more locks to be given out to other transactions. The downside of granularity is that lock management becomes a bit more complicated. We went through an example about that in class where the granularity was tracked as a tree with the entire database at the roots and then going all the way down to individual rows or even individual cells at the leaves, and how that would modify our locking structure. Awesome. Any questions on these particular topics before we switch over to the next batch? Anything else you guys like to talk about? Cool. All right. So then, once we got through all that, we spent a lot of time talking about data distribution. So, data distribution has a certain set of advantages. Like what? Why is distribution so important? What's the big deal? Why can't I just throw everything onto one server and call it a day? Yeah.
We can get more performance if the data is distributed.
Performance is definitely a factor here, but there's another property that we spoke about actually quite often that distribution helps us out with. Yeah. Availability. So availability, again, is the idea, out of a certain percentage of, out of some period of time, what percentage am I able to access? Could be, in our case, a given table or a given database, correct? If I have that database in multiple locations, that increases my availability because if one of those locations goes down, I still have that database on another location, so the availability has actually not suffered at all. In order for availability to suffer, all of the locations would potentially have to go down. So that's how distribution affects us. It's very important. It does involve increasing the complexity of a lot of different operations. So things like, you see 3-phase commit is on here, right? That's an additional complexity that gets introduced once we start talking about distribution. What's the idea behind a 3-phase commit? What do I mean by 3-phase commit? What are the phases there? Or maybe we should back up a second and just talk about how does a commit work in general in a distributed environment? What are the pieces? There's one piece in particular that we have to start thinking about if I'm talking about doing commits in a distributed environment. Is a transaction going to take place in a single location now? No, it's going to be spread out across multiple locations, and in order to keep track of all that stuff, we got to have a transaction manager. There's got to be something overseeing those different locations, those pieces of the transaction that are spread out, that are distributed. So the problem that a 3-phase commit is trying to solve is what happens when the transaction manager has certain failures in certain situations. We can then be left in a state of limbo that says where we're not sure if the commit actually happened or not. We're not entirely certain whether the commit actually occurred or not. And there's no easy way for us to find out. So all of the remaining nodes are then stuck. Do we commit or do we roll back? We don't have enough information to decide. There are certain failure situations that a typical commit will not be able to handle. I actually somebody asked me about this on Piazza a few weeks back, and I put a much more detailed description up on Piazza. So if you're interested in reviewing this particular concept, I would encourage you to go seek out that post and ask any additional questions if you have them. But the way that a three-phase commit solves this problem is it involves a little bit of a, takes a little bit of the power away from the transaction manager, and then it makes it more of a voting process, more of a democratic process, so that if the transaction manager goes down, the other nodes are now aware of the voting process and can decide on how to proceed without the transaction manager having to be present. That's how it solves that problem. Other things that we're interested in when it comes to distributing our databases are how that data is actually spread out. There are two different ways we can partition our data. What are they? Horizontal and vertical. So horizontal partitioning would be, what does that look like? I'm sorry? By entry. So I'm taking, if I have a table, I'm taking, this section of rows, I'm putting them over here, and I'm taking this section of rows and I'm putting them over here. Whereas vertical then would split it up not by rows, but by columns. I'm taking this set of columns, putting them over here, and this other set of columns and putting them over here. Okay? Vertical is slightly different than horizontal because it does require the primary key to be in all locations so that we can stitch those partitioned rows back together again, if and when we need to do so. And how you partition the data really kind of depends on the function that your database is performing for you. There's not necessarily a predefined set of rules. You just have to sit down and think about it. What makes the most sense for your particular application? And then we also went through some examples of data transfer costs. So now that my data is sitting in many different spots, if I'm running a query, I have to make the decision of not just where to get that data, but where to perform operations on that data. And when I say operations, what I really mean is like a join, right? Where do I perform joins on my data, especially if the tables that I'm joining are in two different locations or more. If I'm joining 5 tables together, I could have each one of those tables in a different spot. How do I manage that such that it minimizes the amount of data that is sent over the network? It might make more sense to perform the join, get all 5 tables in one place and perform the join, or it might make more sense to slowly join the tables one after another in different spots, depending on the size of the tables. We went through some examples. We did some math on how to do those computations. A more recent topic that we talked about is security. So we talked about the different ways that security is enforced on databases. So it can be enforced on the user level, on the role level. This is a little bit misleading. We didn't talk a whole lot about SQL injection. We talked a little bit about SQL injection this time. We talked a lot about SQL injection on the last exam. For this go around, we actually spent more time talking about other kinds of security exploits that people have used to gain access to data. This was just on Monday. As a matter of fact, I went through a few case studies, right? A few actual things that have happened. I think, though, I'm more interested for the exam in the general concepts as it relates to security. How do I decide whether data is even necessary to be secured or not, right? What are the questions that I need to ask to determine if I should even be locking down a piece of data or not? What are some factors that might make that determination? Things like that. Any questions on these topics? I got one more round of topics for you, but any questions on these topics before we switch over? All right. Then last, but certainly not least, we talked about data warehousing and how the design of a data warehouse is much different than the traditional ER diagrams that we saw in the first half of the semester. What is the data warehousing design paradigm? What's that called again? What's the data warehouse design look like? Snowflake was one of the two options, or I think more commonly it wouldn't be the snowflake, it'd be the other one, the star schema. So in a star schema, it quite literally looks like a star. There's a table in the middle and then a bunch of tables coming off of it, right? Much like a star would look. So what's that table in the middle called? What is that table? The center of the star or the center of the snowflake. It's the fact table, that's right. It's the fact table. And what's the role of a fact table within a data warehouse? What does a fact table contain? Yeah. Measures, that's right. Measures are quantitative data that can be objectively measured. These are the things that are going to be aggregated and analyzed, right? The numeric information that I'm going to do analysis on. So that's what a fact table looks like, and then there's all the different spokes coming off of the fact table. What are those tables? I'm sorry? Dimension tables, that's right. And what's the role of a dimension table in this context? Go ahead.
Provide context for the fact.
Context, we're asking who, what, when, where. So the fact table is the actual data that's been recorded, but the dimensions are telling us where that data was recorded, when it was recorded, who was responsible, right? Who was part of that, what it was that was being recorded. So it's providing the actual context behind it. The idea there being that those dimensions can be used to be parameters in the analysis that we're performing. The actual analysis is done using cube operations, or the way that data warehouses are manipulated, the way that these dimensional models are manipulated are via cube operations, such as rolling up was an example. Question?
Yeah, question about dimensions.
Yeah, sure.
Can those be qualitative?
Can those be qualitative?
Yeah, like not numbers. The dimensions.
Not numbers?
Yeah.
Yeah, they can be textual. In fact, they often will be. Dimension tables are a lot more flexible in what they can contain. They can contain numeric data. They can contain textual data. If they do contain numeric data, it's more than likely going to be numeric data that I don't expect to be aggregated in any form.
So when we're doing analysis, we're doing it automatically.
So the fact table is where the number crunching occurs, and I believe the statement I made a moment ago is like the dimension tables are providing the parameters. So like I want to know the average sales, but the average sales of what? The average sales over the past year, where year is one of my dimensions, or time is one of my dimensions, right? The average sales that took place in St. Louis, where St. Louis is part of my location dimension, right?
So maybe like fact and tag, all these.
They'll be tagged with each dimension that exists. That's correct. And then you will pick and choose which of the subcategories in the dimensions, which columns of the dimensions you actually care about in your particular analysis. Because not every piece of analysis that's going to be done needs to worry about St. Louis, or even needs to worry about a location at all, right? Maybe I just want to do average sales across all of my stores, and then location doesn't matter at that point. It's not relevant to my question anymore. By having the database split up in this way, it keeps the contextual stuff separated from the numeric data so that we can pick and choose the different kinds of contexts that we want to analyze the data in to answer our questions. And so then the way that we do that is with cube operations. So if I say that I'm rolling up, what is that telling me? I have a cube and I roll it up. What would an example of rolling up be? Rolling up has a start and an end. So an example of starting point and end point would be, yeah.
We could give a very granular set of data, like sales for every day.
Yes.
And then you decide, I want to see sales for like a month.
Exactly. Going from day to month is an example of rolling up the data. What does that entail? It entails taking all of the daily data and just adding it up, right? Or averaging it, or whatever aggregation you're trying to perform on that particular piece of data. So that's an example of a cube operation, rolling up, that involves moving from one level of a hierarchy in my dimensions to another. There were other cube operations that we discussed. There weren't many of them, though. There's only like 3 or 4, I believe. One of the big concepts, one of the big takeaways that I hope you got out of our data warehousing discussion was the idea of online transactional processing versus online analytical processing. There are 2 different ways. We've talked about relational database design. We'll get to NoSQL in a minute, but relational database design, we have ER diagrams on one side and multidimensional modeling on the other side. What is the big trade-off between the 2? If I do multidimensional modeling like we talk about, I gain something, but I'm giving something up as a result. What is that trade-off? What are ER diagrams better at, ER designed databases better at that data warehouses aren't quite as good at? Or vice versa. Why do we spend all this time talking about fact tables and dimension tables? What's the benefit? What's the ultimate gain out of that? Why couldn't we have just used an ER diagram for this purpose? Yeah.
I think in the fact and dimensional table, where we gain analytics speed, so the kinds of queries that we're doing are sped up.
Yeah, and so what kinds of queries are we? You're right. The kinds of queries that we're interested in for analysis are improved. That's the goal. What kinds of queries are we doing? I'm sorry? Aggregations. We're really doing reads. We're optimizing retrieval of data. I don't expect the data in a data warehouse to change very often. I don't expect to make writes or updates or modify that data very often. I have designed the data warehouse in this way because it optimizes read performance, whereas ER diagrams, that ER modeling, optimizes for write performance. How does it do that? What's the big factor that influences whether we've optimized for read or write performance in this case? Yeah. Bingo. Yeah, it's normalization. ER models are very heavily normalized with the 3 normal forms that we talked about at the first half of the semester. Data warehouses are denormalized. And the reason that works is by denormalizing, we actually have fewer tables, which means fewer joins. And fewer joins means faster reads. But slower writes, because I'm going to have redundant data all over the place. I'm going to have duplicate redundant data all over the place. ER models have faster writes because those duplicates are removed. The reading becomes a bit slower because I've got a lot more tables, which means more joins, which is going to decrease my read performance. That's the big trade-off that we're making there. So the really big idea here is that I can have ER models for operational things because if somebody makes a post on Facebook, I want that to be quick. And I can have dimensional modeling for more analytical kinds of purposes because I don't expect to change that data often, and I want to be able to read large amounts of data as fast as I possibly can to perform that analysis. Awesome. All right, and then the final major topic that we covered was NoSQL. We saw what do we see? 3 different types of NoSQL databases, I suppose. Yeah, I think 3. The big one that we spent time with was Mongo, and so you're working on that one right now. Mongo is what kind of a database is Mongo? So SQL is relational. What kind of database is Mongo? It's not relational. It's starts with a D, ends with document. Yeah, it's a document store. That's right. Document store, key value pairs, right? The other kinds of NoSQL databases that we looked at were Redis, which is actually a key value store, but no documents involved, right? Redis does not do documents. The whole idea behind Redis was what was the unique? There are several unique things about Redis, but I'm interested to hear what was your take on the unique piece of Redis that made it stand out from the others. Anybody remember? I'm sorry? It's temporary, or if we expand on that idea a little bit more, why is it temporary? It's session-based. It lives in memory. That's Redis' big claim to fame. Lives in memory. It does not want you to store that data permanently. It's acting more like a cache, honestly. It's acting more like a cache than a typical database. And then the last one that we talked about was Neo4j, which was, what kind of a database was that? That was a graph database, that's right, which was kind of fun to play around with. What are some good uses for a graph database? What might you use a graph database for? Yeah. Yeah, of course. Go ahead. The Zsets? Yeah. The Zsets, yeah. So a Zset is a set, but it allows you, it's a set that's ordered by a Z-score. So it's a set where every member has a number associated with it. And the reason why that's nice is that you can have very quick rankings or orderings. We saw those numbers used. The example we went through in class, the use case was a site with a voting system like a Reddit or a Stack Overflow, where the number represented the ranking of an article, and how you could use those sets to quickly dissect articles by category or by user based on set operations. Yeah. Back to graph. Oh, is there another question? Oh, no, sorry. Back to graph database. What would you use a graph database for? What's a good use case for a graph database? So what does a graph database emphasize? Like, that's different than a relational database. The structure is obviously a graph, right? How does that help us? What does that emphasize for us? Yeah.
It prioritizes relationships.
Relationships, that's right. Prioritizes relationships over the tabular form that a relational database would. So, you know, what kinds of use cases deal heavily in relationships? Social network sites, right? Where users are connected. Recommendation engines are very common. If you like this product, then you will also like this product. That kind of stuff. Just to give one possible example. Another possible example is, you know, think of any data structure that naturally fits a graph. Location data very naturally fits well with the graph, and very naturally works well with graph databases as well, for that reason. As far as Mongo goes, as far as the document store goes, I do think that it's reasonable to ask you to do basic Mongo commands, right? So things that were on homework 5 generally, I think, are fair game. I'm not gonna sit there and go find the weirdest edge case in the spec and grill you on that. That's not my goal. That's not the point. But basic querying, I think, is a reasonable thing to ask you to do. Things like that. Question.
So yeah, so I think in the homework, the update is a little bit different from Mongo's update. I think in homework we basically update a whole JSON object, like we update one whole document.
Yes.
But in the Mongo, you can actually set a specific like attribute of the document. So
I would think that the homework implementation would be capable of that as well. The difficult part there is the implementation, right? Because the way that you can update a document, if the update that I'm pushing is bigger than what used to be there, there's not going to be enough room for it necessarily in the document. So what do I have to do? I have to remove the document, make a new document with the change, and then insert it back in, which takes a little bit more effort, a little bit more work, but it has the same ultimate effect of changing a single field within an existing document.
Yeah.
So I'm not sure that I agree with you entirely on that point. I think the assignment is very capable of doing.
Yeah, I mean the assignment is capable of doing that.
Yeah.
But it's not the syntax. It's not the same syntax as.
Oh, the syntax. Yeah. Okay. I'm not sure. So there are definitely two syntaxes at play here. There's the Java way of accessing Mongo, and then there's the the actual Mongo commands, which are in JavaScript, right? And if you look at the practice exams, you'll see that actually the way that I've handled this in the past is I let you pick and choose whichever version you want. I don't care if you write it using Java code. I don't care if you write it using the Mongo syntax. Whichever one you feel most comfortable with is usually fine by me. So, but I do expect you to be able to do the very basics in Mongo. I promise you're gonna have to trust me on this. I promise I'm not gonna ask anything too crazy, too off the wall. The other thing that I might ask you to consider with Mongo is design. So how does design of a Mongo database differ? What are the features of Mongo that really make it stand out from a relational database? What are some things that Mongo can do that a relational database can't? Yeah. Embedded documents is a big one. What does that contrast with? Embedded documents, how would you try and replicate that idea with a relational database? What would you do instead? Since you can't do an embedded document in a relational database, you would do, I'm sorry? A join, a relationship, primary key, foreign key, right? But the interesting part there is that Mongo can do that too. If you really want to, Mongo can do that too, right? And so what that really provides us is a lot of flexibility. Mongo can use embedded documents, which has an advantage. Mongo can also use the typical, they don't call it primary key, foreign key, but it's the same general concept there, where I hook up documents using some kind of a number, some kind of an ID, and use that if it makes sense to do so in a particular context. So being aware of those two different approaches and the advantages and disadvantages of them is something that I think is certainly fair game for the exam. Even coming up with a design. If I ask you to design a Mongo database, right? I think that's reasonable to do. What does that mean? Typically, and I think there's a question on one of the past exams that does this. If not, I can probably dig one up. You would just draw an example document. Draw an example of a document that would be in this database. Tell me the key value pairs. Make up some data. Tell me the key value pairs that would be in this document. All right. There are certainly things that we talked about that could be on the exam that I did not go over today. We have covered a lot in the last few months. But now, with the remaining time that we have, which is about half an hour or so, according to my clock, yeah, about half an hour, I'm happy to take any questions that you've got. I can answer conceptual questions. We can go over anything from any of the practice exams that you want, any of the review questions from past classes that you want. I might be able to scrounge up some additional review questions if anybody's got stuff that they really want to see or do with the remaining time, but the floor is yours. We can do whatever you all would like with the time that's left. Anybody have anything?
We do number 4 on 2018.
All right, let's do it.
It's design with the MongoDB one.
Cool, yeah, let's do it. Let me pull it up. Number 4 on 2018, you said?
Yep.
All right, cool. Awesome. I remember this problem. So, the problem is asking us to design a Mongo database for a simple social network that allows users to create posts, allows users to like posts, and then it actually asks you to come up with 2 different designs. Maybe a little bit of a spoiler, I probably won't ask you a question that's exactly like this on the exam, but if I'm asking you to think about 2 different Mongo designs, right? The examples that I just was talking about a few minutes ago, embedded documents versus linking documents with like a primary key like value is a pretty safe bet there, right? It's a pretty safe thing to consider to do. So we can try this out. We can try to design it one way. Let's see, did I bring my fancy computer pen today? Oh, I did. We can try this one way with embedded document and one way with a link between the documents, and we can talk about the trade-offs between those two. Let me see if I can get this going here. So let's see, what information do I want to include? Probably need to include this, since that's the problem spec that tells us what our database needs to contain. Now we get to see what we can do here. So a design would just be an example of a document. And honestly, I'm not even sure that I care too much about the data that's contained. I'm more interested in, what keys does it contain and what are the data types that you expect those keys to represent inside of a document. So if I am talking about users, right? If I'm talking about users, this is an example of a users document. Some keys that we would expect this to include, you can see from the description, would be username, email address. So name would be a key, and on the other side of the key, you could either give me an actual name, Doug Shook, right? Or you could even just tell me what the type is. It's going to be a string. I would be okay with that. That would be fine with me. Name's going to be a string. Email address would be probably also a string, right? Are there any other keys that you would argue could be included here? I think we need to include at least one more key here, and that key could have a very big impact on where this goes next. Does anybody have any suggestions? Yeah. Did you have a suggestion, or am I making stuff up? Somebody? No? Posts. All right. So posts. Where posts is, what's the data type going to be? An embedded document. Is that good enough? It has to be an array of embedded documents because I can have multiple posts, right? So it's going to be a list of documents, and then I would need to specify the keys for this one. What does a post have? It has title. It has content. Which are probably both strings. And so this would be acceptable for one design. I don't think I missed anything, did I? Oh, likes. Yeah, likes. Shoot. How would you indicate likes? Within posts, so I could have, what would the data type be? So what does it want to know about likes specifically? It allows users to like posts that have been made. So what would likes contain? It could contain an array of user IDs. I don't have user IDs yet, but I could make them, right? So maybe I need an ID, or I could use username if I assume that the names are unique, that the usernames are unique, or email addresses I would also accept. So even a list of strings I think would be appropriate here. If you included a user ID and gave me a list of integers, I'd be fine with that, right? There's a lot of different ways you could take it that would still work out okay. Yes?
If that was our answer to the question, would we need to clarify what the kind of string would be for likes? Because that, without the context displayed, that's
I certainly think that it would not hurt to add that. Yes. I mean, we're talking hypothetical here. I'm not entirely certain exactly how I would mark this up or how I did mark this up if this happened on this particular exam. I guess I could go back and take a look and see. I have a suspicion that I was probably okay with it, but I don't remember. This was 2 years ago. I don't exactly remember how it was graded at the time. I'm telling you right now that I feel pretty good about it, so that's good, right? That's useful information. So this is just one way that we could design it, and this problem actually asks us to come up with a second design. So how would we alter this design then to come up with a different way? Or maybe before I erase this and draw a second design, let's talk about the advantages of this design. What are some of the benefits of using this list of embedded documents here? What do I gain from doing things like that? Yeah?
Whenever we want a user's post, you don't have to do any sort of joins.
It's very, very easy to see what posts a user has made, right? In other words, the read access on these documents is very good if I have the associated user. If I'm trying to look at all of the posts individually, without the users involved, this is actually worse. Because now I have to traverse a user object just to access the posts when, I don't even care about the user. It's not something that I even care about. So this is one possible design that has some advantages, but also some disadvantages. We could come up with another design, right? And it wouldn't even necessarily change that much. Instead of having posts with, I guess it depends on how you want to do it. Do you have to include posts here at all? Not necessarily, right? Not necessarily. The alternative is to include some kind of ID, which is maybe an int, or you don't even need that if you want to do it by username, and then have a second set of documents. What's a set of documents called in Mongo? It's a collection. Good. So you could have, I don't have a lot of space on this screen right now. You could have posts over here where the ID of the user, right, is included, or maybe you would even call that user. And then title is a string, content is a string, and likes could be a list of ints. Sorry that I had to cram it in there like that, but now I've got two different collections of stuff, one for users and one for posts. And what are the advantages of doing this way? It's like, almost the opposite of the advantages of using embedded documents. If I just want to access the posts, I now have a very clear and simple way of doing that. If I want to know what users are tied to a post, that just became more complicated. Now I have to do some kind of join-like behavior to pull that off. When using embedded documents, I didn't have to. Yes? Isn't that what an ID is?
You have to search for that.
Sure.
Yeah, search for it. The point is, for answering these types of questions, do you have to use stuff that is built in Mongo? Or can you assume the person using Mongo?
Well, as somebody designing a Mongo database, I'm limited to the things that Mongo provides to me. Yes.
But if you decided, okay, I'm storing it like this, you could make queries, or you could find the data on your own.
I suppose that I'm not necessarily opposed to that, but it sounds to me like you're making the claim that you want to revise the spec a little bit to make your life easier, which is fine. I think it's just a little more complicated than it needs to be for this problem.
That would be a fine answer.
I don't have a problem with it. So yeah, we gain the benefits of easier access to our posts at the cost of slower access to seeing what users are tied to a particular post.
What other advantages and disadvantages? Says this
two for each. Yeah. So. That's a good question. I have some ideas. Can anybody help me out? Do you believe me that I have ideas, or am I just trying to make you help me bail out? It's that time of year, you guys. So some other things that you could argue, right? The fact that this uses 2 collections instead of 1, I think could potentially be argued as an advantage or a disadvantage, perhaps. If you look at it from a storage perspective or an overhead perspective, I now have to access 2 files instead of 1. That could be argued as a disadvantage, correct? Or the fact that you have it in 2 files could be argued as an advantage because now those files are going to be a bit more compact individually, which grants you a little bit of flexibility in some ways, right? As one possible example. Actually, including an ID here to link things up is data that I wouldn't have to have recorded if I use an embedded document. So the necessity of including an ID here, if you did that, is an extra piece of data, that's extra storage that will add up that I don't necessarily have if I use embedded documents instead. So that could be argued as a disadvantage against this particular format, right? We've just gone through this exercise. We came up with 2 different designs of how we could implement this database. There are actually many more possible designs that could work here. In fact, you could do both. There's nothing saying that you couldn't do both. I think there are some real disadvantages to that, potentially. But you could do it. You could do it both ways. I could use embedded documents and have a pool of posts. There's nothing stopping me from doing that. Mongo is very flexible. Regardless, though, by having designs like this, sketching out these designs, is Mongo going to enforce this design for me? No. Mongo doesn't care. What's the term we use for that? This is a schema, but it's not a rigid schema. It's not a hard and fast schema, right? It's implied schema. Who's responsible for enforcing this schema? If Mongo's not going to do it, who is? I'm sorry? Us, right? The application layer. The application layer is now responsible for implementing this schema, maintaining the schema. Again, that's an advantage of Mongo from a data retrieval perspective. That's one less thing that Mongo has to do, which should speed up, ultimately, access to your data. Awesome. Any other questions on this problem? I think we still got about 10 minutes left. Question? Yeah, what's up?
There's just an applied schema. Is there anything that stops you from putting users and hosts in the same collection?
Actually, no, not at all. Nothing at all would stop you from doing that. That's a good point. It does make it a little tricky because then you have to go through the additional step of asking, is this document a user or is it a post every time you go through that collection? How much work that entails is probably a function of the design of the 2 documents. I could see situations where that may be preferable. I could also very easily see situations where that would be a catastrophe. Any other questions on this problem? We got about 10 minutes left, so I probably can't do a huge problem, but if anybody's got some questions, I'm happy to use this time however you all would like. Does anybody have anything they would like to talk about for the time that we got left? Anything at all? I mean,
if no one else is going to do one, I guess can we do the other MongoDB one on the other side?
All right, yeah, the other MongoDB one, the other exam. Which one is that? Oh, here it is. Cool. Here we go. Pretty relevant since you guys are working on this homework assignment right now. This is an example of what I was talking about where I give you an example of a document that can be found in a particular collection, and then I'm asking you to write some very simple queries, and you have the ability to use whatever syntax you want. You can use the Mongo syntax, you can use the Java syntax, I don't care. Whichever syntax you feel comfortable with that accomplishes the queries. That's what I'm looking for. it is important to make clear that this, I'm showing you one document here, but this collection actually contains lots of documents, right? So don't just assume that this is the only document when you're writing these queries. First one says, write a query that will retrieve the document for the game titled Bubble Bobble. So if we wanted to do that with Mongo syntax, what would that look like? What do we need? What's the first step of making a Mongo query using the Mongo syntax? First thing I'm going to type starts with a D and ends with a letter that rhymes with D. Yeah, DB. DB's first up. What comes after that? The collection name. So I've told you on the problem that the collection name is video games, right? So far we are at DB, dot video games. What comes next? I'm sorry? Documents? What? Video games is the collection, that's correct. I have to get the documents from the collection, so it's not get documents though, is it? That's not Mongo syntax. Mongo syntax would say, I think I heard somebody say it, find? Yeah, find. And then find is a function. What does find need to do its job? Needs a JSON document. So this JSON document is going to contain what? The key and value that I'm searching for. In this case, I'm searching for documents that have a title of, blah, blah, blah. I think that's it. I think that's what we do with that one. If you're doing this in Java syntax, how would that change? Now for Java, it's a little bit different because if I go back to the exam, whoops, that's not the exam. If I go back to the exam, I spotted you a couple of Java objects that you can use, right? So how would that change? I would go to the collection, and the collection contains a find method. But otherwise, it would look very similar. VG collection.find, and then plug in the document with the correct key value pair as a string, I think would accomplish the same thing. Does that make sense to everybody? I think so. All right. Next one. There's a couple more, I think. Write a query that will retrieve the titles and only the titles for all documents that have a character with the name link. So it's going to start very similarly to the last one with db.videogames.find. We now pass it a document, and if I'm looking for, names of link, I can say name link. The real trick here, though, is how do I make it so that it only includes the titles? What do I have to do? Another document. I need a second document where that document contains, what's the key value pair? Title, and then 1 is the value. I think that would do it. I think that would do it. Yes?
In the schema for video games that we saw an example of, was name?
Oh, was the key wrong? Let's check.
Was name a key because you have character?
Oh, thank you. Yep, thank you. I missed that. Thank you very much. Character is an embedded document. So how does that change my query? I got a little hasty. It's not name : link. How would I pull that out of the embedded document? Character dot name, I think would work. Link. Ran out of space, but hopefully you get the idea. Yes?
So this would, I remember when we were
Do you want to cut those out?
I'm not terribly concerned about that. I definitely remember not caring about that when I graded this problem. But if you wanted to, you could. You just need to add another key value pair here to omit the IDs, right? I wasn't too concerned about that. We got one left, and I think we have just enough time to take a. I think there's one left. We got just enough time to try and tackle it. We are writing a query that will retrieve all documents that have at least one rating of 9 or greater. So if we go back up to the schema here, I can see there's a ratings list. I can see there's a ratings list down here. I want to find all documents that have at least one rating that's greater than 9. This one's a little bit tricky. Like the others, it would start in a similar way. So with the DB and the video games, so db.vg, I'm going to try to leave myself as much space as I can here. Find. How do I check that array to see what values are in there? What is that going to look like? In. I think in could work. What would that look like? What would the syntax be? I assume I need a document, right? What's the first step? Rating. So the name of the key that contains the array, and then what? Another document, and then in with the $sign out front, right? And what's the value here? I think it would just be an array with 9 and 10 in it. Bracket, bracket, paren. I think this would work. Yes?
What if you didn't know how high the ratings went?
What if you didn't know how high the ratings went? Good. I think that's a valid question. I don't know. I don't remember if the problem stated anything about that or not. I feel like some people did. So in this case, I think it's very valid to write on your exam, assuming 10 is the highest rating, and I would totally accept that. But if you, excuse me, if you wanted to avoid that problem altogether, it would necessitate changing this query a bit. Instead of in, I think there's a different operation we could use. I think you could use greater than or greater than equal to, whichever you want. Greater than or equal to 9. I think this would also work. I'd want to plug it in and try it to make sure. I feel fairly confident that that would work. It's possible I made a mistake somewhere in here, but I think it's a reasonable attempt. Unfortunately, I don't have enough time to fire up Mongo at this current moment, but if anybody does have a chance to do that and test this out, I would appreciate some verification on Piazza. Otherwise, that's going to do it. I will announce office hours as soon as I know what they are. I have my regular office hours tomorrow, so if you want to come chat with me tomorrow morning, I will be there. I'll announce office hours for next week as soon as I know what they are. Otherwise, thanks for a great semester, everybody. Good luck on your finals, and I will see you on the 16th.
These types of find operations that have like